logic vectors, and that just means that they have 1, 0, and a couple of other special ones like high impedance, low impedance that you don't have to worry about for now, but they're there in case you start needing to worry about them for later. We're going to make one more. We're going to have a result, and he's going to be an output. And again, standard logic, because it helps to have things that match up. You can do it without matching them up, but it gets a little bit messy. One note there, I just deleted the semicolon at the end of standard logic. VHDL needs that in order to do the port. It actually has it right here. So that's one kind of weird programming construct that you need to wrap your head around. Finally, now that we've defined what our simple object is going to be, we're going to end it. So we're going to end simple object. Okay. Now let's save our simple object. We'll save him as, and this is something that you'll also need to notice, we're going to call him simple object VHDL. The name of the file must match what the entity name is. Otherwise, Quartus will throw a fit, it won't compile, and you'll spend hours beating your head mercilessly against the computer wondering why it doesn't work. Not that any of us have done that. Alright, so now we have a simple object, but we probably want to make it do something here. So let's define what it does. In order to do that, we need to create what's called an architecture for it. We do that by using the architecture keyword. So the architecture, and you can call it whatever you want here. So we could call it foo. I like to call it behavior, because that's what we're modeling here. We're modeling the behavior of our simple object. So the behavior of our simple object is, and now we must begin in all bold. Caps actually doesn't matter in this. Be sure that your variables are all named differently. It is not case sensitive. It will not pay attention to that. But we want to just put that same function onto a result line again. So here we go. We're going to say result is assigned A and B, which was our AND gate right here, or C. So we have the output of A and B, which would be this line right here, getting ORed with C coming along here. And that goes to our result. So now we just put a semicolon there and say end behavior. That's it. Pretty simple, huh? So now we're just going to save it once more, and we're going to compile it. In order to compile it, there's a couple of different methods. There's a button on the drop down on the side here. Should be this guy, analyze, or you can try to compile him from up here again. In order to do that, there's a little trick in Quartus that you have to notice, and we'll come over here to simple object, and you left click on him, and then you'll right click set as top level entity. Anytime you hit compile over here, it only compiles what it considers the top level entity and anything that's necessary to make that top level entity. So if your project does not include our simple object, it won't do anything. So for our purposes, we want to make him the top level entity, and then we're going to hit start analysis and synthesis. Once again, it'll compile. It's saying, oh god, I'm a horrible programmer, I should give up now. And now we can do some analyzation here. So the architecture behavior is expecting a line here, and that's right here that I forgot a semicolon. So we fixed it, and now we'll start our analysis and synthesis once again. Yes, we want to save. And there we go. No more embarrassing lacks of semicolons for this programmer. Okay, that's great and all. So now we've compiled it once again, but what can we do with it? Well, let's say that we want to drop it onto our schematic here. We want to have a function that does something cool. And we might want to tie it into some of our lines that we've already written down here. Like, I might want this A, B, and C to hook up to that file that I just made. So let's go back to it. We're going to go to File, and we're going to go to Create/Update. We're going to go down to Symbol Files for Current File right here. It's going to do a little more compilation once again. It's going to say it was successful, and that's awesome. So we're going to come back to our project here, and we're going to go once again to the Symbol tool. We click on him, and now there's this little project box right here. And that project box has our simple object. But if it wasn't in there, for instance, if someone just gave you a VHDL file, you can just go here and browse through anything that you want to browse through again. So we're going to grab him, we're going to say OK, and we are going to put him right here. So that looks pretty spiffy, huh? A nice little object that has just 3 lines to it and a result. So let's hook it up to some stuff. And in fact, let's hook it up to the exact same things that we have running into our gates. So we're going to hook up our A line and our B line and our C line. And I'm just going to copy and paste. And now I have another pin for result that I can rename to VHDL result. So now we can compare the two of them and see if the functions are the same. And we'll connect him up. We'll save and compile. Everything's good to go. So now we can come back to our vector waveform file, which is right here. And we can go once again to Insert, Node or Bus. We're going to find the nodes again, list all of them. And it didn't find it. Which is odd. So, give me just a second here. We have our output. We will compile him fully. And once again, we have warnings here. This is saying that we don't have a license and we have unused pins. So, result has no output capacitance. That's quite all right for us. So hopefully our vector waveform file will find it this time. So once again, we'll come into here, insert node or bus, node finder, list. Oh, excuse me. I know why this is doing it. Again, it caught me. So because I compiled that and this wasn't the top level property, top level entity, it was compiling our simple object VHD. So we'll go back to him, make him the top level, and try again. And I will apologize for wasting a minute and a half of your time on that. Okay, so now we're good to go. We'll come back once again into our waveform, insert node or bus, find the node, list everything. Haha, there we go. Click on him and put him into the result. Okay, so we'll save, and we'll come back over here to our simulator tool. We have to generate a netlist again. It's successful. And we will start once more. Simulation's done, and report. So yay, here we go. We can see that the result, which is the one that we drew by hand, is the exact same thing as the VHDL. And we can scroll through and see that it's going to do the same thing over and over and over until the end of time. So we're successful. So that's two ways of looking at a project, essentially. What you have here is a schematic capture version, which allows you to draw things in by hand, which can be very handy for connecting up objects that you've designed internally. For instance, if I have a bunch of these little VHDL objects, I want to wire them up, I can just copy and paste them all over my diagram. And all I have to do afterwards is just wire up where I want them to go and what I want them to do. But for the internals, some of these guys are great to do in VHDL because instead of wiring things up by hand and clicking and dragging objects around the screen all day until your eyes bleed, you can just write a little bit of code right here. So we can copy and paste this and reuse this code over and over and over. So I hope this helps you to see a little bit of the versatility of VHDL, and in the future episodes of this, we'll go into a little bit more of the interesting things that we can do with VHDL, and we'll start to show you some of the magic behind it. So if you have any questions, comments, or concerns, you can email me. Otherwise, I'll see you in labs on Thursday. Thanks for listening.